Oh, shit. All right, guys, welcome to part 2. We're going to try to build a 486. I have pretty much what I need, with a few exceptions. Like, for example, when I ordered or bought an IDE interface card, I got a cable with it that is too short for this chassis. So I won't be able to plug in my CD-ROM drive. It's also a single IDE chain. I wanted a dual, but anyway, what I want to do before we dive in is I want to go ahead and look for any... Oh, shout out to... I forget who you were, but somebody pointed out that this is an ECS Elite Group motherboard. Apparently, there was a telltale here. There was a model, UM486. Apparently, that comes back to an ECS Elite Group. Now, I thought ECS Elite Group built junk motherboards. I might be thinking of their newer products, but this board looks to be pretty high quality. Really nice glossy solder mask on this thing. Everything is labeled. It's a nice board. It does appear to be a good quality board. So, all right. Or maybe it was this. This is the Southbridge UM82C482 UMC. So we're going to start off by going through this Creative Labs Sound Blaster. This card, it has some sketchy looking caps on it. I don't want to sound like a capacitor alarmist, but literally all of the electronics that I've worked on over the past 2 years, every single thing that didn't work was due to bad capacitors. But I want to clean this up a little bit. Look at that rework. That's classic. Just go ahead and add that. We'll just tap that onto there. Just, factories had to do what they had to do. These had IDE interfaces, but they were only compatible with certain CD-ROM drives, and you had to run the drivers too. Generally, when you bought a Creative Labs sound card, you could get a sound card, CD-ROM, and a set of speakers in one box, and it would all link to this card right here. But we're going to go ahead and do these caps, just get them done. I think I have all of these in stock, so they're all mostly 1016s. So let me go ahead and swap those out real quick. Looks like that one's scratched. Yeah, let's go do that first. I'm just going to go ahead and work on this. All right. I'm going to mark off my 1016s because I know there's a lot of them. Then I'm going to count them out and we'll get them out of the inventory. Oh, we got a 51, a 51. Okay, 1016, 1016, 1016, 1016. Nope. Why are we doing this? Good question. Glad you asked. Because we can. Normally I would just throw this board in, but I don't want to waste my time when I know damn well these caps are all from the mid-90s, which was not a particularly great time period for capacitors. They tend to fail a lot, and we're just going to swap them out. It's not worth it. The risk of having one, go either open circuit or short is just not worth it's just not worth it. So just swap them out, get it done. 1016. Are they 10 volt 16 or 16 volt 10? 16 volt 10s. Had myself going there for a second. All right, I got enough of those. I'm going to grab a couple of 51 throughs. Yeah, I got a few of those left. I've got a resupply ship coming, so that's not a problem. I'm just going to pop them all out, and we'll put in new ones. What was this one? These are wind caps. There's another 1016. Oh man, they really used a lot of them. There's I wouldn't say there are two differing schools of thought on this. To recap or not to recap? That is the question. And the answer is it depends. It really depends on what you're working on. I mean, there are some eras of electronics are notorious for capacitor problems, and 1994, 95 was not a good time. So I'm all for doing them from that time period because it just makes sense. Just as a little prophylactic measure. If the caps are not bad, or I'm sorry, are not good, and I fire this thing up, what's going to happen? Well, chances are the amplifier, the onboard amplifier, will not work correctly, and it may not sound great. I just want to get this out of the way, basically, is what I'm saying. For some reason, this cap doesn't come out. I'm going to test some of these, too. We'll see. Oh, Jesus. It doesn't want to come out. I also don't want to pull any traces. No, I think I'm okay. I've never had that problem before. Either in especially tight. Which one was it? This one. Okay, it came out in one piece. Oh, look at that! It's leaking! Am I good or what? It's leaking! Here, let's see if it's any good. First one we pulled, I can see a little bit of a crustiness underneath it that I don't like. Maybe not. Maybe not. That could be just. Well, let's just see what it tests out as. I'm gonna replace them anyway, but all right. Well, it's not too bad. 9.48, 3.7 ohms on ESR. 9.48 capacitance, microfarad. A new one. How does that compare? 10, 3.8. So ESR stays the same. Capacitance goes up a little bit. So I'm all right. Let's proceed. We're gonna pull the rest of these out. But these are very small leaded caps. The holes aren't very big. And let's give it a few seconds to heat up there. All right, well, that's not fruitful. I'm going to kind of roll that around. Okay. Am I suggesting that you go and recap every piece of equipment you have? No. See, what I'm doing, I want to give this thing the best possible shot at success. I don't want to be spending the next month of my life troubleshooting aging hardware. So what I want to do is, because I've been through this before with other systems, I just want to get all the shit out of the way. All the stuff that's going to ruin this experience and make my life a living hell, just get it out of the way. So I'm going to do the same thing for the video card if it has any electrolytics as well. And the motherboard doesn't have any at all. All the capacitors on the motherboard are tantalums, so those should be okay. Or they're ceramics. Tantalums and ceramics, they don't go bad quite like electrolytics do. These have a special way of failing when you don't want them to. So there, soapbox. I'm done. All right, let's repopulate the earth with 16 volt. I'm gonna clean this board real quick. This is really gross. I'm gonna clean this board. We'll take this 30-pin sim off. I still don't really know. I think this is a buffer, but The 30-pin RAM, I don't quite get why they had them on these. I'm not really sure what that was all about. But I'm going to clean this really well. All right, let me do that now. Psych. Actually sitting in a tower case because all the dust is on top. If it were in a desktop, it would have been like this, and it would be pretty clean by comparison. We're going to clean the fingers, all of the contacts on the card edge connectors with alcohol and a microfiber cloth. That works for me. I'm only showing what works for me, and a lot of these methods I have been using for a very long time with no issue. So I can only speak for myself. Now, I've already replaced the 16 volt 10 microfarad caps. Those are all done. I'm going to do the 50 volt 1 microfarads. And so anyway, I'm going to continue on with this cap job. I'm not going to drone on and on about caps because, I mean, seriously, do we need to do that? I don't think so. One of the things that I also do on these, we're going to want to clean these headphone jacks, or these audio jacks. And to do that, we're going to be using two things. We're going to be using compressed air. Okay, I found this NXT brand compressed air, which I think is from Amazon. This is the best. It has a larger diameter straw, and it just really packs a punch. It's the same thing as every other brand, but it's a bigger straw, so you get more. You get more out of it. But we're going to use that. We're going to blow through every single... I've already done this. I did this. I thought I was filming, but I wasn't. Whoops. But we're going to blow all the dust out of these. Then we're going to go and take some deoxit. I use the deoxit D5 is what I would use on that, and that's what I've already done. If I was filming, well, we wouldn't be having this talk. But I use the D5 deoxit. I don't use the one-shot can, which is my D100. I use that for other more precise things. But we just shoot this a little bit, just like that, into each jack, and let that sit. And then you can take your can of compressed air and you can blow out any residue. So we'll do that. We'll do that at least. Just go like that. There we go. That's all. Just clean those up because those usually get pretty gross regardless. So I'm going to finish the job and catch you in the next step. All right, so now we're going to do the interface card. I actually tested every cap that I pulled on the sound card, and every cap was fine. So, in all transparency, it didn't need to be recapped, but we did it anyway because just get it done. So these are probably a little bit cheaper. This is a no-name Taiwanese card, or Chinese in this case. So they're probably not as high quality as what we pulled from the other one, or from the Sound Blaster. Let's take a look. These are 2510s. It's 25 volt 10 microfarad. Let's see what we get on this one. So, in short, no, it's not necessary to recap all the things. But I generally err on the side of caution because, again, these don't get better with age. So what you see today for value, all right, 9.8. That's I would say that's probably, see, 10% of 10 is 1 microfarad. So these are, yeah, I'd say they're within, well within 20%. So 20% of 10 is 2. So it can be as low as 8 microfarad and still be within 20%. As far as what the spec was on these, now these probably weren't 20% caps, but let's take another one out. All right, these are tin plated, And there is definitely a haze on these fingers. We're going to take some... This is also controversial because you got to be mindful that these tiny little invisible fibers can get lodged in places that you don't want them to. Okay, you don't want these to be left behind, so you want to be very careful. But we're going to just buff the contacts with the steel wool. There's WD-40 in this steel wool, and we're going to make these all nice and shiny again. Okay, both sides. And like I said, you want to carefully inspect the board. If you're going to use WD-40, I'm sorry, steel wool, you're going to want to inspect that board after the fact for hairs. Okay, but look at how nice and clean those are. Then we're going to take this microfiber cloth and just kind of polish them up. Look at how nice that is. See, if we didn't do that, it doesn't mean that it will fail, but it probably wouldn't be successful. So I guess it would probably fail. But we're going to just check the board, make sure there's no little hairs of steel wool, because they will light up like a filament if we leave any behind. So that's what we want to make sure we don't do. I think I'm ready to start assembling, but we have to look at that power supply next. That power supply is a big question mark right now. I have not put power to it, so I'm going to pull it out of the case and we're going to crack it open and check it out. All right, this power supply is positively disgusting. I don't know if this fan will be any good, but I have my doubts. I don't think I have any good ones on hand, so we'll have to probably shelve this project until I can find one. But we're going to blow this out in the garage with the compressed air. This thing is gross. Kingspow is the case manufacturer. I think that's how it's pronounced. It is a Taiwanese generic case. I mean, as generic as it gets. The front cover, here. I had to pull the front cover off to get the power switch out. And it actually does say Kingspow right there. And I remember, so if you've been watching the whole series on this, my cousins actually had this exact same case. And I had to work on it for them one time, and it definitely said Kingspow on the power supply. So it was no question it was the same freaking case. But this power supply is now 32 years old. A big question mark as to what the state of it is. I may have some caps for this one too. In fact, I'm planning on replacing them anyway. At least whatever I can. But it's just very dirty in here. Haven't turned it on. I don't expect any issues. But I see an oily film on it. That's interesting. We got a bunch of 50 microfarad ones, 50 volt 1 microfarads. I don't have it. I think I have 2 left. Or 1. I think I used them all up. I have 1 left. So I can't be replacing those. But some of these big ones that I had initially bought for the IBM, I might be able to replace. I think I bought some of these. I just don't want to light it up unless I know everything is kosher here. 54.7, 51, 54.7. What's this guy here? It's like a 50. You can't really see it. Let's just clean it up and fire it up. What do you think? Think we should do that? Let's do it. All right, I think we're gonna just gamble. We're gonna roll the dice. I just cleaned this up real good. I don't really see any residue on the board from caps. I do see some of this waxy stuff that's not related. That's just like a coating. Nothing's leaking. Although this brown stuff, no, I think that's just yeah, that's a really poorly applied potentially. Yeah, maybe these are bad. Well, we'll find out, won't we? We're going to power it up. I'm going to plug a hard drive into it just to see if it'll take a load. Highway to the zone, danger use. Highway to zone, danger use. Highway to zone, danger use. A little bit of steel wool and make it look pretty. Oh, that was a bad idea. Oh my God, what was I thinking? Okay, back to the air compressor. I just noticed I put little tiny specks of metal in. No, don't do that. Don't do that. Oh, that was dumb. Highway to zone, danger use. That was stupid. I'm gonna need to borrow a power cord from my oscilloscope because I don't want to run another cable. So here we go. So I got my I got 2 hard drives on it. I'm gonna maybe put a third one on there just to give it a good workout. Let's put 3 hard drives on it. I want to put a load on it. I want to see what she can do. All right, this thing only, oh my, this thing only has 3 Molex plugs. We're going to use all 3 of those. We're going to have a CD-ROM, hard drive, and I'm putting in one of those floppy emulator things. Can't think of the name right now. Okay. Here we go. I don't know if the switch is on or off. Let's see. It's off. Okay. Let her fly. Please don't blow up. Okay. That's 3 hard drives. 1 5 1/4 and 2, well, 2 of those quantum Bigfoots. Big feet. Fan is spinning. I don't hear any noises. No whistling, no popping, no crackling, no funny smells. We're going to let it run for a few minutes and see what happens. We might be okay. We might be good. This power supply might be just the lucky ticket to make this thing run. I do intend to recap this. Just getting that out of the way. Just not today. I don't have what I need to do the job, so we'll do caps. I'm also getting a new fan for it, just to get that done. But it's holding the load. I'm gonna let it run for a little while. All right, so I've finished our bench testing of the power supply. Get a little bit of a load test, if you will. So I think what we're gonna do now is we're going to just go ahead and start reassembly. So we're going to put the power supply back in. And we'll get that stage out of the way. We'll slide our motherboard in. We're going to have to use some of the plastic standoffs from the 386 board. I think I'm missing some. So yeah, so we're going to need to pull some of those off. I'm glad I had that board because I don't want to have to go finding more of these. Okay, so let's go ahead and put our motherboard in. So I've got all of my interface cards. So what do we need to build a 486 desktop back in the day? Well, you need a motherboard. This board is pre-populated with a 486 DX33 chip. I may upgrade this to a DX2 once I find one. They're not hard to find. I just haven't looked at all. It's fully populated with RAM. I don't know how much. I can only speculate as to how much. But I'm going to look at these. Yeah, these slots aren't too bad. They're not really dirty. It should be okay. What's interesting is this is a complete matching set of memory. They are all the same manufacturer, same capacity. So probably some even number like 1, 2, 3, 4, 5, 6. Could be 8 megs. Could be 16. Could be 12. We don't. Well, it won't be 12. Could be 2, 4, 6, 8. Yeah, it could be 16. Could be 8. We don't know. This is an early 486 motherboard, so it uses 30-pin SIMs. Later boards would have used something more like a 72-pin SIM. It's easier to connect our front panel connections when this is all apart. So we're going to try to match up. Now the hard drive one is always the red and black. That's always hard drive. That one, are these labeled? No, they are not. They are not. We have to actually look at the back of the panel to see what they are. The case manual would have had all that info. This guy here is a key lock. What I don't know is, oh, pin 1 would be probably the blue one. So this is, yeah, this is our key lock. And it's black, blue. At least it looks like a key lock. No. No, I don't think so. All right, let's try to figure out the ones we do know. All right, hard drive is, like I said, it's going to be the black and, let's see, the black and red. That's going to go into the interface connector. So that is not on that is not actually on the board. The black, green, and gray. That looks like it might actually tie into multiple things. Sweet. So with these older boards, it actually is beneficial to have a manual because it will tell you what type of RAM it requires, how to configure the jumpers for the amount of RAM. It's kind of complicated. There's just so much stuff that you have to know that you didn't necessarily need to know before. This thing supports a CGA display, apparently. I mean, wow. But what I'm looking for are the pinouts for the connectors. Let's see. Key lock and power. Pin 1 is 5 volt. So pin 5 is ground. So this is a combined. Yeah, that's exactly how that goes in. Perfect. That's all I needed to know. Speaker connection doesn't matter. Actually, it kind of does. Well, it does. It does matter. But the speaker goes here. Pin 1 is going to be your positive, or your, yeah, positive. Let's see. Turbo LED, pin 1. Yeah. So I see a theme here. Turbo LED is going to be the yellow one, I think. Yeah. I'm going to rewrap these cables and make them all clean and tidy after. Oh, wait. What's this? Is turbo switch? Or is this the key lock? Which one goes to the damn key lock? It's way the hell over here. I don't... Looks like it goes that direction. Black and white. I see black and white. Oh, I already took care of that. Never mind. Turbo LED is this guy here. LED, LED, whatever. That goes here. Turbo switch. That is the middle button. And that is also black and white, but it's mixed into this. Oh, I see why. So, all right, normally open, normally closed. Got it. That's what they've done there. So they've taken it as normally on or normally off. I just figured that out. So we'll try it. So there should be one common pin. We'll just try it in this position here, because I really don't know. We'll have to figure that out. That's how you know this is an early 486 board. 30-pin SIM turbo switch support, which allows you to clock it down. Now this is probably going to be our reset switch. Now it goes all the way to the end, and it is our reset switch. I was correct. Put it in the same orient. Doesn't matter. Orientation doesn't matter on that. Okay. That takes care of our front panel connections. You kids today will never know the pain. You just won't. I think they standardized this shit years ago. A couple of things to note is back in these days, you generally had knockout plugs on the back of your case. And those are for your auxiliary plugs, like, for example, your extra parallel or serial. So the interface card itself, if the board didn't have them built in, your interface card would have two built-in connectors. In this case, it's parallel and 9-pin serial. But this also came with a game port, which is kind of cool. And we should have a knockout plug that can fit a game port, but we don't. No, we don't. So we're gonna need to do two things. So let's take a look at what we have here. This is kind of a little confusing. So this case came with the headers already mounted in the case for 9-pin and parallel, but we don't need those, so we can take them out. This board supports an auxiliary COM2, okay, which is going to be our, that's going to be our 9-pin, actually 25-pin. Where's that 25? Where is it? It's over here somewhere. Where do I do it? So this is a 25-pin serial, and it only uses 9 pins. So we're going to plug that in. We're going to take this parallel port out and put this in its place. Actually, no, we're not going to do that. We're gonna. I got a better idea. I'd rather have two 9 pins, because I'm going to use the 9 pins more often than 25. Well, I guess it doesn't really matter. I mean, we could do this. We can do this. All right. What I don't have are the blanking plates to put back. So I kind of wish the game port could be used in one of those, and then I wouldn't need that slot cover. See what I mean? So let's see what we can do with what we have here. I don't have one handy. You know what I'm talking about. So we'll just loosen these up. Because the Creative Lab Sound Blaster has a game port built in, I don't need that extra game port. So what I'm going to do is actually just remove this extra 9-pin. And I'm going to have to find the configuration guide for that interface card, so I can disable the onboard game port. Nothing is labeled. Oh, it is. Okay. Let's see. HDC, COM1, COM2, HDC, enable, disable. HDC. Hard drive controller. Okay. We'll leave it as, oh, here we go. Game port, enable, disabled, jumper 6. 3, 4, 5, 6. So that we will be moving out of its position and putting it into the disabled position. Yeah, that's what we'll do. Now this is where you have to kind of pay attention. Now we could put the sound card anywhere we want, really. The memory slots are spaced out just so that I could fit it right between, but I don't really want to do that. What I could do is, rather than putting the sound card, I just realized the sound card is the one that's most likely to be affected by electrical interference, and having it next to anything of any importance is probably not a great idea. So we'll put the video card over here. If I can get it in. Come on now. I get the impression that the board is actually misaligned just a hair. So we're going to loosen up the retaining screws and kind of slide it back a little bit, just like that. You know, there's not really much room. Or the back of the, you know what? I think the back of the case is a little misaligned. That might help. Oh, there we go. Okay, perfect. All right. And now the sound card can go right over here, like that. Yeah, and it doesn't interfere. If we have to take out that rear SIM or that bottom SIM, we would have to pull the sound card out. But yeah, it's okay. All right. I don't think I have everything I'm going to need to get this thing up and running with an OS today. I'm pretty sure I don't. I'll explain why in a second. So, one of the issues I have is I don't have an IDE cable that is suitable for this application. I have a very short IDE cable, but I can't hook up a CD-ROM drive. That's the issue. I can't hook up a CD-ROM drive at the same time. I actually have ordered a 20 or 24-inch cable that should facilitate that. So I think that's all I needed for this build. Let's go ahead and prep the drive cage. We're gonna pick out a hard drive from the collection. I think I have just the ticket for this one. Let's see what we got. All right, what we have here is a Seagate ST3144A. I believe this is a 400 meg drive. It actually came out of a computer that was built in 1994, so it is kind of on point. So we're going to mount it in the cage. I got to dig up the correct amount of screws. But this drive should work just fine. It's actually a bootable Windows install, Windows 3.1. So, although I'm having a hard time getting it to fit in this. Well, maybe not. No. Maybe not. Interesting. It's almost as if the drive cage wants me to install it backwards. Let's put this in. Gotta clean that. A lot of grime in here. Clean that up. There. All right. So what I'm going to do is I'm going to just throw that drive bay in place. I don't like how that interference fits with the power cable. Let's get that out of the way. The power cable is so definitely in the way. And it wants to pull some of the front panel wires, and there we go. It's still not right. What's in the way now? Oh, there's a screw in the way. All right, hold on. Now this is an issue that caught me really off guard. I didn't get this case with a hard drive in it. And this Seagate is just bog standard 3.5-inch drive. Normal. I compared it to several other drives. The mounting points are totally normal. There is no way to properly mount a hard drive in this bracket. It just cannot be done. The case itself is in the way. No matter how I orient the drive, yes, I can mount it, but I'd have to knock the front cover off, which, I mean, like, permanently, which I don't want to do. But there's no good way to mount a hard drive. None of these screws holes line up. I could drill holes, but that's not in the build spec. Okay. Oh, I could do one hole, one on each side. No, that doesn't work for me either. There is I didn't expect this problem. This is a weird one. I've never seen this before. Usually these front drive cages, they're designed to accommodate a hard drive. Not this one. So it's time to light the fires and kick the tires. Will the 486 from 1994 Tribute Build PC actually start up, or will Oreo jump on my bench and knock all my shit off of it? What do you think's going to happen? All eyes on you, buddy. Are you going to knock my shit over? The choice is yours. I hear your mouth opening, but nothing's coming out. Is that a yes or a no? Yeah. Cats are going to cat. Okay, so the deal is this. I have to pet Oreo first. I did not name him Oreo, by the way. Amelia did that. Just saying. I would have named him something else, like Gordon Whitefoot, or he has white feet. All cats pretty much have white feet. But I think Gordon Whitefoot or anything but Oreo would have been appropriate. But okay, will this thing actually run? Will it run? I don't know. Everything's hooked up right. I checked a few jumper settings. I didn't look at any of the logic board jumpers, but I'm afraid to press the go switch. Here's what's going to happen. We're going to hear this. Beep, 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 beep. You watch. I didn't turn this on, so I don't know what's going to happen. But I predict beep, 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 beep. That's my prediction. Here we go. Smoke test. Take one. Oh, shit. That was prophetic. That was the sound card. The one that we recapped. I was joking when I said that, you son of a bitch. What happened? What the fuck happened? course, the first thing you do is you check polarity. Make sure they're all in correctly. Well, that was unfortunate. Yeah, something on this card let go. Don't know why. This capacitor blew up. Yep. Yep, it blew its guts everywhere. This board might actually be salvageable. We'll just have to put another... oh, shit. Did I really do that? Oh, no. It's my fault. It's my fault. You know, I put it in backwards. I was looking at the wrong plus sign. Oh, you bastard. Let's see if it... All right, we'll fix that later. That should be fixable. Fucking A. Ah, I put it in... Ah, that has never happened to me. Seriously, I'm serious. It was this guy right here. And the plus... Oh, man, I was looking at this plus sign over here. Ah, you motherfucker. That was completely my fault. I take full credit for that one. Fuck. All right, we got 3 lights. Do we have post? Yes, we do. 8. Yeah, I was close. 8, almost 8 megabytes. Okay, press F1 to resume. Standard CMOS. Let's see if it detects the hard drive. Yeah, it does not detect the hard drive. Let's do it. There's an auto select, so I think it's page up, page down. User, is there an automatic? No. There is no automatic. It's too old. Yeah, there's no auto. So let's I don't have the parameters. But it does post. None of these are for the correct size. That's okay. That's not a big deal. We can work with that. Let's just pick one at random. 31 megs. Floppy disk A should be 1.44. Yep. Okay. F10. Yeah. Let's see if that helps. So it's doing its... See if we get any activity on that hard drive light. Oh, now it says 8 megs. It's trying to read from it. Okay. Oh, Easy Drive is on there. Kick ass. It's not bootable. I know the drive is bootable. What we'll have to do is that's really got Easy Drive on it? That's impossible. Yeah. Yeah, this is an old board. Fuck! Alright, let's fix what we broke. We got lucky, though, because I don't think it caused any further damage. I'm pretty sure. That happened so fast. I mean, it could have blown something up, but I think it's unlikely. Got to watch your board layout, guys. 100 microfarads, 16 volt. Let's see. Grab one of these. Let me show you what I did wrong. Not that you need me to show you, because you probably all already know. So here's the deal. I'm going to show you my mistake. And maybe it can be a learning opportunity for not just me, but you guys as well. We're going to replace this and hope to God that this card works, but we won't know for a while. Because I'm not going to be able to put Windows on this for quite some time. I'm very busy this week, so... But yeah, I blew the cap right apart. But if you look on the board, there's a plus mark right here. That is what I was looking at, but there's also one over here that I missed. It's an honest mistake. It can happen to anyone. Get off your high horses, guys. It's an honest mistake. So it's got to go this way, not the other way. Is that what I think it is? Oh no, it blew, oh wow. It blew the electrolyte completely all over the board. We got to clean that up. Unbelievable. It could have been worse, guys. I mean, sound cards can be replaced. You know, nobody died. Nobody got killed. Jesus Christ. Well, let's just hope. I almost did it again. Let's just hope that everything's fixable. Really, though. Really. And it did it on camera. Right on cue. I said, smoke test. Turn the power switch on. Oh, man. You know, the fact that I'm going to leave this footage in should tell you a lot about how humble I am. Let's take this thing. Let's finish the disassembly on this one. See what's inside it. Yeah, you can see there's a coil of electrolyte impregnated paper in there. That's all it is. That's all it is. You know. And let's get this out here. There's some like film. You got your anode, you got your cathode. This is it, guys. And when you send the power the wrong way, it all unravels like one of those party tricks. Pretty cool though, huh? Look at all that stuff. Yep. Well, there's 10 cents down the fucking drain. Unbelievable. Let's solder it up. Oh, shit. That's not great. We'll solder it up, we'll put it back in, pretend this never happened. Nobody speak a word of this. I want to take this moment to say this much. There are times when it's better to just leave well enough alone. Okay? If we had not changed these capacitors, which weren't bad in the first place, we wouldn't be in this situation. I just noticed that my power cord on my desoldering tool was touching the tip. That's not good. It wasn't touching it, it just got very close to it and it was melting. So, all right. My little clipper tool. Where did the clippers go? I have another one here. No, I think I have to go back and grab it. All right, I've decided to do a little different course of action here. I've got this Bigfoot 4.3 gig drive that's just doing nothing, and it fits in a 5 1/4 inch bay, so why the hell don't we just use that, right? Who's with me? Show of hands. Oh my God. I put that card back in. I've got an any disk, bootable diskette. Oh, I should clean that drive before we do anything. Now, the 4.3 gig it's weird how it counted to 8 gigs or 8 megabytes this time. All right, so we don't have BIOS settings configured for this floppy drive because we took the power out, we shut it down. So actually it did preserve it, but it's not booting. It's hanging on boot up. We might have to pull... I wonder if that card is damaged. So let's pull it out. Yeah, there's probably some additional collateral damage going on. Pull it out and see if that fixes it. Or if maybe the hard drive is causing it. Maybe the drive itself is causing it to hang. Let's try this first. We definitely... Okay. That's no fun. Okay. Here we go. The fact that it does post is promising. That is really promising. This is wait. No, it's... Oh, oh, no. Okay, it is the hard drive that's hanging it. Let's, because with any disk, you can run any hard drive. It doesn't have to be anything special. I gotta pull this jumper. I'm gonna try a different jumper position. There we go. Pull this jumper out. I'm gonna try putting it in CS or cable select. We'll leave that out for now. We'll worry about that later. What I'm not getting is any... oh, you know what? I know what we missed. Floppy drives generally require power. It's not necessary sometimes. Of course, I'm being completely funny. Let's try this. Yeah, it's looking for a drive that's not there. It's basically what's happening. Here we go. We're getting somewhere. There we go. Does it boot seek on that? It does not boot. There's nothing there. There's a cleaning disc in there, just in case you didn't catch that. I don't want to put any of my good discs in there until it actually gets cleaned. So it's supposed to fail. Okay. I can take this out now. It doesn't like that hard drive. So, well, why would it? So what I need to do is let's go back into little Control-Alt-Delete. There it goes. So let's go into BIOS. So let's go ahead and look at this. So I have it set to like the smallest. Let's put it... I don't think it matters what we set it to. We'll just put the largest one that it will accept, which is like 150 megs. Oh yeah, 150. Oh, this is a really old BIOS. But that doesn't matter. With any disk, it doesn't matter. I want to put, so we've got a bootable disk in there. F10 setup. Oh, it's not F10 on this. Yeah, there it is, F10. The more I think about it, the more I think that my cousin's PC had the same board in it. I have no way of confirming that, though. That's a bootable disk. Let's see what it does. It's not even trying. You know, we may have to do some additional troubleshooting. Oh. Nope, there it goes. There it goes. All right. Should be, here we go. Any drive, let's see, any drive. Well, F-disk, no. This utility is a wonder if you're trying to restore a vintage PC. Here we go. Please send $5 per machine to Christopher Lammeter. Okay. Tool rearranges the MBR so that the drive parameters will automatically be patched. It uses the BIOS area to adjust. View current settings in master block. Any drive R. Restore master boot block to normal. Remove any drive. Any drive. Okay. Some type that allows Android to modify the master boot block. Maybe any setting will do. Okay. So I need to get the drive specs for this drive to make this work. Okay, good news. It runs. I put this, ooh. Yeah. This drive is really small. I know it's not this small in real life. But according to this, it's like 124 megabytes. I don't think that is correct. I think this drive is bigger than that. But it actually does run. It's got Windows 95 on it. I don't know what computer this came out of because I don't recall ever having a drive that small. Bob Durrett. I don't know who that is. But it reports 8 megs of RAM, which is correct. Let's take a look at all the yellow flags in the device manager. There will be a lot of them. Oh, wow, really not that many. Actually detected it as a standard VGA. That's impressive. But that is incorrect. Let's see if we can do better. Let's change driver. I don't imagine it, well, I guess it doesn't matter, huh? Super VG. Oh, Sierra. Cirrus Logic. What do we got? Turn this thing on so I have power on my phone. Or is it dead? Oh, it's dead. You suck. Alright. So I made an assumption, and I shouldn't have. The assumption I made was... Hold on. Yeah. There's a way around this. You gotta, hold on. The assumption I made was that the BIOS wouldn't support anything more than like a couple hundred megabytes. But here's the thing. It does. If you use the custom setting, you can put in, it actually detects it as a type 47. It gives me the correct drive size and everything. 4,300 or so megabytes. It actually does allow me to use a massive drive like this. 4.3 gigs is massive. So I might have found a use for that quantum after all. I'm not going to go any bigger than that. But it turns out that my Seagate that I was planning on using this entire fucking time was only 130 megabytes, which makes it a really good replacement drive for the Toshiba Portable, but not much else. In fact, even that is 100 megs. I won't even waste my time with anything that small if it's going to be a Windows machine. So what I'm doing now is I'm actually going to install Windows 3.1, I think, is what I'm going to put on this ultimately. So what we have to do is we have to run fdisk. We have to format this drive into chunks. I'm going to do 4 1 gigabyte chunks. So let's delete any existing. See, 4126. Delete 3. Delete primary. Oh, delete non-DOS. Oops, I hit the wrong button. Let me do this. I'm just going to roll with it. Delete non-DOS. So you have to know what the cylinders, heads, and sectors per track is. Once you have that, you can go into the BIOS and just tell it what the drive is. And it will, depending on the BIOS, and I'm shocked because this BIOS is from 1990, 91 maybe. And the biggest drive you could buy off the shelf back then was maybe 250 megabytes. So that's impressive. I'm really impressed by that. We'll see if it works. So create DOS, set active, for do create DOS partition, create primary. I do not want to use maximum size because we're on FAT16. So we're going to do percentage. Let's do 25%. Let's put the percent sign in there. Okay, there we go. Create DOS partition. Create extended. Oh, my washing machine's off balance. Nice, nice, nice. 25%. Okay. What did I just do? I'll create logical drive in the extended partition. So, percent of disk space, 25%. Okay. No, that's not correct. Hold on. I gotta pay attention. I'm getting distracted by that. Okay, so I made some progress. I was able to adjust or set manual drive parameters, and it did pick up the full 4,100 or so megabytes, but F-Disk only sees a small portion of that, which is not great. I'm only seeing 473 megabytes of total disk size. That's F-Disk, so that's not normal. I'm gonna figure this out. And my washing machine's off balance, so I'm all distracted now. So I am listening to that eat itself apart. And now I got to worry about this. So I got a lot on my plate. We'll get through this together. Well, maybe not, because my battery's about to die and I can't film anymore. So we'll pick this up later in another video, and we'll talk all about it. And until then, guys, have a great night.